So it's actually a couple of days later now. I wanted to get a valve in here just so I could drop it down on some Prussian blue just to see where it was, make sure it was seating properly. Obviously at 1.5 hour run out or 12 tenths is not going to be an issue really, but started getting back onto this because I wanted to cut a new seat on the valve. So I'm missing some bits. I've done some 3D printing. So there's a block under there now which I've 3D printed, which holds this setting fixture, which basically allows you to redo multiple valves over and over again. So once this is set up, which I think it is tight now, you just slot a valve in, touches these points, and then you can just obviously look at the DTI, which has got 0 fucking markings on it. And you can just wind her in. Yeah, I can't see any markings on there. I will have a proper look, but I'm pretty sure that had nothing on it apart from this one mark there. I assume this is supposed to have a ring around it, but nonetheless I suppose I could put a paint mark and just run it into the same point every time to skim off the top. So this block, a few iterations of trying to get there because it's swinging and hitting pins underneath, so I went through a few of them. I basically got it so it can now, there's, like I say, there's a couple of these are pins that run through the other side. I don't know if I'm going to be able to, I don't know if you can see the pins. You can just see one of them there. So this then locks, so it has to be exactly the right size, so it stops there, stops there. So I managed to get all that and the sizing and the height right. So, well, say the height. So you have to put a valve in like so, but this has to be on the piss to get that valve in, but then when you straighten it up to come over here, it's too low. So I don't really know, or too high, I think it's too high for the valve. So I don't really know how to solve that problem. Just, so yeah, one second. My patience is running thin with this machine. So that goes in there, no problem. And then one would assume that you'd have to move that around there, wind that down so it's roughly right, and then maybe rotate this. It won't. Yeah, I mean, but that's obviously one, for me to put pressure on that. I don't know if you can see it. Yeah, you can. For me to put pressure on the stem and then rotate it, that's scratching the stem up. Like there's just no way that it's not scratching the stem up. I appreciate the stems might be hard, but yeah, that is definitely going to scratch the stem up. So I don't know about this yet. And again, these stops, because of the height that it's at, it almost looks like I need to drop that down a bit. But if I drop that down, I'm not so convinced that that's actually going to fit in there. Because I mean, I can't go a lot if I can. Because I'll probably go 4 mil. 4 mil before then it's past the centre point. And here, that's like 10 mil. Unless I move this shaft that way, which is starting to push the boundaries. If you look at this block, that hole isn't that far away. I'm going to break one of these open really. There we go. So that hole isn't that far away from that bore. Well, I mean, it's like 2 mil. So I can't move it that way at all. Unless I start moving, no, because it goes right the way through. So all I can do is move this shaft down. And then once it's straight here, because these aren't height adjustable, it's going to start causing issues with it going over centre. So one of the issues I am having is that this cam drive changes the angle of this shaft ever so slightly. So it rocks it. So basically this shaft angles like that. Now the issue I'm having is that this wheel is not grinding perpendicular or flat to the, or 90 degrees to this. You can see that heavy side. It wants to float round. Yeah, it's not 90 degrees to the thingy. So I've got one of these little angle gauges. So I stick that across the bottom down there, shine a light through the back, and I can see that the opposite side to this side, the side you're facing, so this side over here, it's basically sitting at a slight taper like that. Like so when you grind the valve, it doesn't touch this front side, it only touches the back side. So I'm going to mess about with that a little bit before I go any further. I'm just going to crack these off. So I don't know how much this is going to show up. And that's touching that like that. Yeah, look. So it's barely touching. It's now touching heavily. But the issue you've got is miles away. So that's nowhere near touching. That's just touching. So is that the same both sides, or is it? No. That's further away if it's anti-clockwise. Drag that across. Appreciate that was terrible. That's closer. That's further away. Okay, so fully anti-clockwise should correct my issue potentially. Let's wind that out. Fully anti-clockwise. There's no way for me to see it. As soon as I put this wheel on, you can't hear the grinding disc. Like you can't hear it grinding. So you don't know if you're sparking out as such or anything like that. It's so soft. I can't hear the damn thing. So I'm just spraying liquid down here at the minute. Okay, I'm going to do it like this. You listen, you won't be able to hear this for shit. Keeps popping out now for some reason. I don't know if you could see that or not. You zoom in a little bit. You can just see it. And getting covered in shit. Right, so the question is now, not that you're going to be able to see it, but just push this up a little bit. If I stick this behind here, I mean, if it's gone the other way, then happy days. I've got enough adjustment in the whole machine to take up the play that's in that spindle. Oh, it does look like it is the other way now. Oh, yes. Oh, that's really good. Yeah, so now we get to play around with setting that up. That's really good news. Right. Oh gosh. Oh man, that really does look pretty good. Alright, I'm going to try a valve. Because that does look pretty darn good now. There we go, just touched on. I'm actually just going to roll that off. Will it let me do that? No. I'll take it right away up. Right, so we can see that is caught the corner of that valve. Just going to check that. No, we're still missing a patch. We're still missing that little patch there. Get back into it. Right, so I don't think I can put a 45 on any of these, but I'm going to tip them all. So when I put them in the concentricity tester, they're all going to be pretty good. So we should be able to set this up. So that's there, that's there, that's there. So then we should be able to just pop each valve down, tip them. I need to pull that off. I need to probably wind that in a little bit more. Hoses are like a little bit in the way of this. Either way around. And that's probably a big no-no. But either way, we're now set up, that is tipped. I do still have some of the 45 on there. So we're just going to do them all to that length because I mean, I'm cutting off so much anyway. It's not like I'll be reusing these valves. Right, so wind back to here, and we will see that, but that is one shiny surface. Right, so last thing I'm going to do quickly is actually just check the concentricity of all of these valves, even though I've only actually cut 2 of them. Alright, so let's put in the non-faced and non-tipped valve. We have, I'm gonna say that is hard to fucking read. Potentially half a thou, maybe 3/4 of a thou. Not the easiest thing to try and do. Yeah, you can see fine. Let's see if I can turn it around now. Obviously, you know, me wiggling it, not turning it, this gauge isn't the best. I'm saying that's 3/4 of a thou. This is a tipped valve, non-seat cut, or no seat cut, or whatever you want to call it. Are we sitting in a good place? Hold on. Where are you looking? Yeah, you can see. Oh, of course. Oh, there we go. Back on. So that's tipped. I mean, I'm just going to call that a thou. It's so close, it's going to be like 9/10. I'm saying that it's 7/10 all day long, maybe even 8/10. That's a thou of anybody's money. Money. Right, last one. Oh shit, mate. This is tipped and the seat cut, and this is the last seat I cut with all the corrections. So this should be absolutely spot on. And it's probably the worst one. That's right at a thou. I'm going to get the 10th gauge on this. I should have an adapter now. Alright, I've put a different gauge on here now. It's a shit clock, but it doesn't really matter. And I'm just going to zero that. It's a real shit clock, obviously. silver line for the best quality. So down to 0, not quite 0. So that's 0.03. So 12 tenths, so just over 1 thou. So there you go. That's shit. Right. Just before I finish this one up, this is a brand new Super Tech valve. So this should be interesting. Also a lot bigger. It just seems to be going up and down all over the shop, like it's nowhere near. Let's just try again. Have you got all that? Yeah. This is up and down like a yo-yo instead of being out of concentricity, which it is, obviously. So this is the same, 0.3. We just grab one of them LS valves. I do not want to drop that valve. Like I say, this isn't the best because it's missing its oh fuck me. Yeah, you can still see that, cool. Can you see the 0 though? Bit of bloody view, no. That's on 0 for me, so screw you. Well, there's 3. Okie dokie, well, that's also 3. Alright, so still figuring it all out. I've got a new dial indicator coming, which is, so this one's lost its ball. I don't know if you can see that, but it's lost its ruby ball off the end, but it's just a silver line one. Still a bit shocking, but nonetheless, I don't think it's even that old. I think I've used it twice. So I bought a Matutoyo one with a hardened carbide, like tungsten carbide ball on the end, I think it is. Either way, it's a bigger dial as well. So it's still 0.1 millimeters or 0.01 millimeters. This dial is so hard to actually see. Obviously they're thousandths, it's a small dial. So to read half a thou is quite difficult, where obviously this is 0.01 millimeters, which is basically 4/10 of a thou for each increment, which is easier to see for sure. But I've checked every one of these valves with this tool, which means because it's not got a ball on the end anymore, I have to go in one direction only. So I've gone through and I've actually, oh, this engine is blue on that, but these ones I can't get any better than 0.02, I think it is now. So it's just over a thou. Or might be 2.5, I don't know, because I tell. The only ones I've actually ground on are these two and these two up here. So these were 0.03, they were in this row. And yes, I know they're not in line in any way, but this is just how I measured them and I added as I saw. I've managed to get them to 0.01 now, so that's within 4/10 on those. So that's not too bad. Now what I can't get is, I can't get these ones remotely to do under 0.025. So the fact that this is centerless, and it really doesn't matter, because it's centerless, it's not like it's in a chuck and it could go sort of up and down and be cocked in. This is completely centerless, so they're up against pads that never move. So it doesn't really matter if the pad is, let me zoom out a little bit. Oh no, it won't let me. These good phones. It doesn't matter whether it's pissed like that, pissed like that, pissed like that, pissed like that. It doesn't matter, because either way, the stone's just going to grind an angle in the wrong direction. But if it's pissed like that, it's just going to rotate in that direction and grind an angle that's not 45, but it's still going to be concentric. So the only thing is I can think is, well, that's the way I see it. You know, the only way you can get a centerless valve system not to work properly is if the valve is actually pissed. So maybe these are not straight. That's the only thing I can think. I don't want to ground a new valve, especially if I stick the new valve in that tool and it runs well, because what's the point of grinding that? Especially if this machine is actually going to make it worse. Because I can only get these ones, and let's say these were straight, 0.1 is the best I can get. I don't know why. Maybe it is because all of these valves are just never going to be 100% true. So, I've got the head out because I'm trying to rebalance it. I'd realised that the angle gauge that I was using, this is a different one. This is just a Chinese one. I'm pretty sure this is B&G Racing on it, but they're just imports. They're like 100 odd quid though. So I've just taken it off my camber gauge clamp for the wheels, and this is what is it? It's 2 minutes. So 0.02 is the increment, and you can see it flashing between the two there. Where the other one was 0.05. So it could have been, two and a bit minutes out easily, or 3 minutes out really. The only problem is the magnet on this one is so much stronger that it's very hard to place it up there without it sucking towards one of these bolts. So whether it's getting lifted up, that is a whole different thing. And obviously I've got, the balancing I've now pretty much nailed. The seat run out, I've now got it to 12 tenths, so just over a thou, or what's that? It's going to be like 0.02 or 3? 2, 8, that's 8 tenths. Yeah, so it's going to be like 0.03 of a millimetre, which to me is still too much. But what I did just do, I don't like the concentricity test as in, so this is one of the ones that's ballsed anyway, as in I can't get it any better than 0.025 on run out on this. Obviously the guide's worn as well. Now it's not worn heavily, but it's worn a little bit, and I think that may be, I might check these guides quickly. I have checked them before, but it's been a long time. I think that the reason I can't get any better run out is because obviously the guide isn't perfect for the pilot that I've got, and the next pilot up is too big to fit in this. So it's only a couple of tenths if it is, but it could be a couple of tenths at the bottom, a couple of tenths at the top, which allowing it to wiggle. I don't really like doing concentricity tests where, people put a bit of grinding paste and then they lap it in, because that one high spot on the valve could mark that whole seat. The way I prefer to do it is to put a bit of engineer's blue on, basically put the valve in, and then slap it down. I can't do this with one hand, so. Right, so engineer's blue on the valve, put the valve in, and then don't turn it, because as soon as you turn it, now I definitely slapped that down harder on this bottom surface. And just so we are all, I've put an L here, which might look like an arrow, but this is actually where the low side is on the seat. So if I just pop that straight out, now, like I say, I would have definitely pushed more pressure down on this side because I slapped it in that way, but there was actually quite a little bit of friction there. So if there's any high spots, you should be able to see them, or low spots. Oh gosh, that's not good for anyone. But that has a decent seat all the way around, although be it mottled. But that's expected. But actually that low point, oh my gosh, that low point hasn't shown up. So that's interesting. But I'm looking at that, and yes, it's a bit sparse in places, but it's actually pretty good all the way around. It's pretty even all the way around. There could be one little low spot just here, but the light isn't showing it the way it actually looks. It's very minimal. The only thing I can do is slap it in again. Yeah, I mean, that's definitely going to take up some low spots, just like grinding paste would. And the grinding paste that I've got, I haven't tried it yet, but it's actually lapping compound and not grinding paste, which is what most people are going to use. Because the grinding paste is just going to obviously grind a seat, where that's not what we're trying to do. We're trying to lap a seat to see where the mark is. And I'm sorry, but 400 grit is not really a lap as far as I see it again. That definitely went in better. And I don't know if you felt that little bit of, not stiction, because it's not a shock absorber, but certainly a little bit of vacuum on it. So we can see, oh yeah, we can see it without the light, hopefully. Oh, wrong way. So I'm saying that's pretty good. I'm quite zoomed in there, in the right place. If I spin that, I don't know if I'm going to be able to spin it with my hand. Oh yeah, I can. That'll give a much nicer seat. Now I only went probably 15 degrees or something rotation on that. Oh, not 15 degrees, maybe 90 at the most. You can see that's now a full seat. No problem at all. And that's all 45, so that bit that's not touched is just, you know, the valve's just sinking in that much. So, and I know that, you know, everything has a tolerance, nothing's going to be perfect, I get all that shit. No, that doesn't mean I don't want it to be perfect. But this is definitely, I'll just show you. Let's say this is a ground valve, and it's interesting as well. So out of all these valves, these are all the measurements. Now this is give or take some of these, you know, 1.7. That's just me guessing what it is, because obviously it's. But this one, this single valve has 0 run out. So when I come to grind this one, this will be the real determining factor. And I'm not going to grind it until the SERDI engineer's been. But this will be the determining factor of if I can grind this valve and get a 0 out of it, then it's all working fine. Because this is currently 0. You've got 12 tenths on the seat, 12 tenths in the valve. You could have 1.2 thou that way and 1.2 thou on the seat this way, which means then you need 2.5 thou really in the guide clearance. And I don't know what this is, but you need that. Otherwise, you imagine, well, as far as I can see it, you know, if you've got 1.2 thou that way, 1.2 thou on the seat, at some point they're going to line up perfectly, you know, as the valve rotates and goes through its motion. It might stay there, but at some other point you're going to have potential clonking where the valve head is moving, and if you don't have that valve head play catered for in the guide, then when that closes and it's slamming closed, you're going to get a deflection where the head of the valve is going to rock. And it's going to rock to the point where it breaks the head off eventually, because if you wiggle metal enough, through fatigue, it's going to crack and fall off. And that's why I think a lot of the Honda heads or having Supertech valve issues, because the job's just not done right. Like, so people say, oh, the Supertech valve, the heads fall off of them. And I'm like, yeah, but they're not a bad valve. Millions of people use them. Supertech aren't doing anything about this potential issue. And is it an issue, or is it the fact that people have just got really shit guides to valve run out? And if, you know, I don't think this is that bad. I have got a head which has had some machine work done to it. Ready. Right. So we are at, what is that? 11/10, and she's pretty straight until you get to the bottom where it becomes absolutely horrendous. So we're the top, man. Oh yeah, the very top's a bit shit. The very top is dog shit. So I'm just going to check it at 90. Yeah, the majority of this guide, I think there's actually a step inside there. It feels like there's a step. The majority of this guide is actually fairly straight and consistent. Yeah, I can see some kind of step on the top of the guide on every one of these. I don't know why, but that is what it is. That is on every one of them. There is a small step about 3 mil from the top, and I can feel it jump into it, and that's what that massive jump is. But nonetheless, so we have got 1.5 thou, pretty much all the way through. Let's just check this one. None of these guys look in bad condition. There's that, got that step there that takes it through one. That is 2 thou. Just run through them all, why not? Sure. And 1.5. Oh, was that 1.5? Sorry, I was miles away. Oh yeah, no, 1.5. Right at the bottom, we're up at 2, but it's 1.5. And then we've got that really weird step. That's 1.5. Or 1 or whatever. That's 1.5. I'm going to go back to that first one as well. Yeah, and we are 1.5. Let's just do that first one, the first couple again. Yeah, so they're only, oh, sorry, yeah, 1 1.25. It's confusing. Yeah, that's, I mean, that is 12/10, so 1 thou, 2/10. Actually, first I'm going to show you whether you'll like it or not. The run out, get rid of that Prussian. The run out on this seat, bear in mind this isn't a multi-angle seat, this is a dog shit single 45 that's about 3 mil thick currently, or at least 2.5 mil. So you wind the tapered pilot down, and I've probably shown you before, but you this is fully repeatable. So you blow the guide out, you put it back in, blah 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 blah. I can do this all day long, put it back on and get within 1/10 of the same thing. So this was 12/10. Let me just put that on 0. Can you see that? Not fucking really. Let's zoom in. Good. Right, so I'm calling that 0. I'll probably just knock that. It was 12/10 before, and look at that. It's now 12.5, maybe 13. Yeah, maybe, no, sorry, yeah, 12. Yeah, so there's 13, and I think the other one was exactly the same. So obviously, it's repeatable. I think it'd be better if I go the other way. So it's the same reading. I think it's about 1 thou. Might be slightly under 1 thou. I've only cut those two on the exhaust, and that was with the new setup. All the others I cut with the head slightly unbalanced, I believe. Let me go and show you the other head. Alright, so I've got this cylinder head that's been done. Obviously I didn't do this. So these pilots from New Way don't actually mic up what they say they do. 0.005, I think that's what they're out, something like that. But what that does mean is, especially these guides, have got a fair amount of clearance in them. I think they've got something like 2 thou clearance in them, which means, and this is the thing, I mean, I'm just too fucking anal for my own good, but like, so this pilot in this guide falls right down to the bottom, where in this guide there's no way that doesn't go down to the bottom. In this guide there's no fucking way you're taking that down to the bottom, not without flaring out the top of the guide, and obviously they're tapered, so you know, enough force so they certainly would do. I think I did this guide. Yeah, that one's sticky. See, look how high that. Can you see that? Not really. Right, so the difference between this guide, which is all the way down in the seat, and you can hear it, that is that surface there hitting the top of the guide, to this one, this currently has, so just like that, and even if I push on top, that has like 15 mil? 15 mil further, and to get this to work you have to wind that down a bit. But even then, that, like I say, I push that as far down as I'm happy to, because these are quite tapered, these guides. You know, there's probably, they go down to about a 1 mil wall thickness at the very top. That's still like 10 mil difference. Like, and I say it's got a fine taper, right? I get it. This is all going to need resetting up, and of course that's there. I don't, can you see that? Okay, well I can't change the angle of it. Can I change the angle of the head? Is that any better? Certainly looks better, doesn't it? This does not. But you get the point. That's 2.5 thou. Pretty consistently actually. In fact, I'm going to write that on there.